We're looking at the gas law practice worksheet, which you can see now has Boyle's law, Charles' law, and Gay-Lussac's law all mixed up in the same paper. You probably want to write all your laws down. You got P1 V1 equals P2 V2. That's Boyle. You've got your Charles law, which is V1 over T1 equals V2 over T2. And you have your Gay-Lussac's law, which is P1 over T1 equals P2 over T2. And we're going to work through problems 1, 2, and 3 together. And we're going to identify each law and solve the problem. So you go through just like before, find a number, label it. Milliliters is a volume. First one we come to, we'll call it V1. Its pressure changed from 75 kilopascals to 150. So we've got P1 and P2. New volume means we're solving for V2. Since we have pressures and volumes, we can see that Boyle's law is going to be the one we use. And then we just plug our numbers in. We've got 75 times 475. And we've got 150 times V2. Solve for V2 by dividing both sides by 150. I'll give you a second to put that in your calculator. You're going to want to do 75 times 475 divided by 150. And that answer is 238. So you'll mark that out of your answer bank. Units match V1's units, so they are milliliters. Okay, now we're going to look at number 2. We have a sample of neon gas at 50 degrees Celsius. That's our T1. It's at it has 2.5 liters for its volume. That's V1. And it's cooled to 25 degrees Celsius. That's T2. Remember, we need our temperatures to be in Kelvin. So you add 273 to your Celsius temperatures. T1 is going to be 323 Kelvin. And T2 T1, let's redo that. T1, okay, that was right, 323 Kelvin. And T2 is 298 Kelvin. And you'll put in 2.5 over 323 equals V2 over 298. And if you cross multiply, get V2 by itself. What should go in your calculator is 2.5 times 298 divided by 323. Give everybody a second to plug that in. And your answer is 2.3. We're solving for volume. V1's units are liters this time, so V2 is also liters. Alright, and we've got volumes and temperatures here. Anytime you compare the volume variable to the temperature variable, you know you're going to use Charles' law. And one more, number 3. I am going to go ahead and erase this so that I have some room to write. We have fluorine gas at 300 Kelvin. That's our first temperature. It is already in Kelvin, so we won't have to convert. It has a pressure of 500 torrs. That's P1. To what temperature should it be lowered to bring the temperature to 300 torr? So P2 is our question. Nope. P2 is given here as 300. To what temperature, T2, is what we're solving for. And since this one we're given pressures and temperatures, we can see that that's going to be Gay-Lussac's law. And if we plug in 500 for P1 over 300 for T1, and P2 is what we're solving for, so we'll leave that as our variable. And no, P2 is 300. T2 is what we're solving for. So that's our variable. And we just cross multiply. To solve for T2, this one, when your variable is in your denominator, it's just a little bit more difficult, not much. Sometimes it helps to write this part out though. 500 times T2, 300 times 300 is 90,000. And if we want to get T2 by itself, divide by 500. And T2 is 150 Kelvin when you divide that. Give myself a little space. So there's an example of a Boyle, a Charles, and a Gay-Lussac. And you have some more to do on your own. And you should be ready to do that now.